Thanks, everyone. So up next, we have Laurent Slatz from the Things Network. The Things Network were one of the workshops, actually the first workshop of the Summer Academy. And it was Laurent and his colleague Frank that, welcome, that did the workshop. And I'm just gonna, I know you have a whole amazing overview, so I'm gonna give a tiny little description. The Things Network is a global community of 15,983 people. Is it growing or higher?
Hit the 20,000 already.
Ooh, that's great. Over 20,000 people across 86 countries who are building a global Internet of Things data network. And I'm just gonna welcome Laurence to come up and we'll pull up your presentation. So welcome.
Thank you for the introduction. Some of you might know parts of my presentation since I gave it like last week during the summer camp. And some know this thing as well. You might have seen it there at the side of the table. But this is basically a node which you can connect to our network. It's basically an Arduino, small computer with a sensor and a LoRa module that you can communicate wirelessly. So I can press it around. I soldered it myself, so please try not to break it right away. So my name is Laurens, and in the next 50 minutes or so, I'll shortly explain what the Things Network is about. Partly I'm going to talk about decentralized networking as well. Dive a little bit into the technology and mainly focus on how we build a global community of now over 20,000 developers within 2 years. Do I have the fancy thing where I can... Oh, wow. Perfect. So let's first... Oh, great. Thank you. I have a few slides about the Internet of Things in general. Some of you might have seen these kind of graphs where there's an exponential growth in devices that are connected to the Internet. So they say, I actually don't know, I think we are at this point about 8 or 9 billion devices that are connected to the Internet. And they say that up to 2020 there are 30 to 50 billion devices that all have some wireless connection and can be connected to the Internet. Pretty impressive, but everyone is shouting different numbers. No one really knows how that works. But at least the guy who started with this, at least coining the terminology Internet of Things, was called Kevin Ashton. He mentioned it in 1999 for the first time. Worked at Procter & Gamble, and he wanted to have better insights in the stock of lipstick, and he was using RFID tags for that. Now, he named the words Internet of Things, and from then onwards, this became a big thing in today's society. If we have one year later, we had the first smart fridge. It's a nice train again. It's first smart fridge, developed by LG. And this is kind of the example everyone gives if they started talking about the Internet of Things. Well, their fridge could handle emails, you can watch television, pay bills, and handle personal banking. Apart from keeping food in it, so it's pretty handy, I'd say. Actually, because most of the people think this is not a very good example of connecting things, so they make these kind of meme websites. You can have a look at it. It's pretty fun, so I highly recommend it. Well, if you take a few years later, what is this, 2007, 2008? Well, Cisco mentioned that the Internet of Things was really born because around that period of time, the number of connected devices exceeded the number of people walking around this earth. So pretty impressive. And people became a bit scared around that time because we simply would run out of IP addresses. So that's one of the reasons why they started developing the IPv6, which could allow this number of unique IP addresses. Well, at least enough for the upcoming years. The Gartner hype cycle, for the ones that are familiar with it, is a kind of an adoption curve about novel technologies into society. And in 2014, the Internet of Things hit the so-called peak of inflated expectations. And if you would follow this curve, then you would see that like around it takes around 5 to 10 years before it reaches the plateau of productivity. And that basically explains that the technology is widely adopted into society. It can be easily implemented for reasonably low pricing. So now it takes a couple of more years, but at least like starting from this period of time in 2014, the expectations were tremendously high. Like everyone is talking about it. I actually don't know what's now on top, but I think autonomous cars is like a little bit past it. Probably maybe some machine learning or something. I'm not really sure, but at least like a big topic everyone is shouting about. And if you then look at like the technologies that are familiar, or at least that you can find on the market today, then you see like the smart fridges, smart toothbrush, can like detect your brushing behavior. Smart fork, also like kind of eating behavior detection, I suppose. An X-ray, last example, is pretty fun as well. You can connect it to your favorite sports team, and it goes off once your team scores a goal or anything. So good fun, nice examples, but I think this is in a very big contrast to like the slide I showed before, where it says like the peak of inflated expectations, where it would change like the way people behave and people live, and then you see these kind of like fun gadget-like examples. Few slides about some radio technologies, so we can dive more into it later on if you would like. So like a lot of times like these kind of technology are used. So you see a lot of Wi-Fi, 3G, 4G is coming up now. You have Bluetooth. So like the basics M2M communication that some of like you mainly heard about. It's basically just having a 3G or 2G SIM card in it and like communicate then, which is pretty expensive, or it's quite often can be pretty expensive and consumes a lot of battery. So it's not very suitable for battery-powered devices that you just deploy in the field. But it is very suitable for transferring very large packages of data for us to watch Netflix or Spotify on the go. It's pretty handy. But like specifically for this battery-powered connected sensors, for that like this LoRa technology is very suitable. Let me explain a bit more. So there are 3 variables. Like this is very simple radio technology. So my colleague is actually sitting there at the back, so you can dive into more later on. Romeo, he's one of our tech guys. So I hope you are not offended by giving this super easy explanation. So you have 3 different variables. So you have range. So what is the maximum distance you can like send a signal between the sender and receiver? So how much battery or how much energy you consume by transmitting that signal. And how much bandwidth you can use, so how much data you can use per message sent. So for example, if you focus on, let's say, 3G network, then we see that like the range is very high. You have these very big, like these cell towers which can have like kilometers of range. You have a lot of bandwidth because you can like stream music and stuff, but it uses a lot of battery, so you have to recharge your phone every night. So if you have like Bluetooth, certainly you have also the low power variations of it. Then you see that it's relatively battery efficient. You can still send quite some data. Like you can also use it for music streaming and stuff. But the range is very small. And if you then apply this to LoRa, you already see it. Then the range is like extremely large, like up to 10 kilometers. It's very efficient on its battery usage. It can, if you like program it smartly, it can last for years. The downside of it is that you can only send like very small packages of data using a very low data rate. So it goes up to 5.5 kilobits a second, and the maximum payload size is around 200 bytes. So that's not too much. And like we did a cool experiment where we like filled a big helium balloon with like a very small device that only transmitted, the transmission power is only 25 milliwatts, because like that's the maximum power allowed. We like had it lifted up into the air up to like 22 kilometers and something, and the maximum distance was 333 kilometers measured. And like for the ones that are familiar, at least for the ones that follow the workshop, you might like understand this. But like, we used like the fastest data rate, like mentioned as of 7, spreading factor 7. So you can either lower up the data rates, and that allows you to reach even further distances. So like this is a pretty impressive technology, I'd say. All right, enough about LoRa. Let's talk about the Things Network. Around 2 years ago, that's around the period where this technology was invented and like hit the market. So a few guys started here, and they thought, all right, this is like pretty an amazing technology, because apart from the long range connectivity and low battery usage, it's actually pretty low cost. So the sensors, now we just made myself, I think that cost 20 euros with all components, and like you can make it a bit cheaper as well, certainly if you like start making this in a year or so when it's like furtherly adopted. And like these base stations, so these antennas for this network would have like these large ranges of a few kilometers. Well, they cost, let's say, about 1,000 euros. So we started looking at the map, and we saw, all right, if you would just have like 10 of those antennas, place it at some strategic high locations in the city, we can basically cover up the whole city for an investment of, well, let's say 10,000 euros. And even better, if we then open up this network, then for an investment of 10,000 euros, the whole of Amsterdam can use this network with so little investment cost. So this is what we started with. Oh, we even wrote a mission to build a decentralized, open and crowdsourced Internet of Things data network owned and operated by its users. So eventually the idea is that like together with all the users, with all the people that are using these kind of networks, we can like have this kind of investment. And everyone owns, for example, the antenna, or several people own the antenna, but the network itself is not from any party in particular. I will dive a little bit more into this in a second. But like from the very early beginning, so a bit less than 2 years ago, we found these kind of partners in Amsterdam. And within 6 weeks, we rolled out this full network in Amsterdam. But yeah, network in itself is not that valuable. So we also created a first use case, which is called Hoosje Bootje. And that's a very small water detector sensor that you can place in boats. And I guess for the ones that like are looking around in these kind of areas around the canals, then you see a lot of these kind of boats that are making a lot of water. Certainly in autumn. When there's a lot of heavy rainfall, then you see a lot of these kind of boats. So the use case was you have a small water detector sensor, and if the water is attached to the sensor, like the owner of the boat gets a signal. Do I have a slide from it? No. He gets a signal on his mobile phone. Your boat is running water. Do you want a service to come by and get rid of the water? And if you reply yes, please do, then a service comes by and you're all good to go. Very first use case. So it went pretty good after that. We had a big launch event, and we came featured in some pretty good global news blog sites like The Verge and The Next Web and stuff. And from that onwards, it started becoming like we expanded very, very rapidly. So within a couple of months, we had presence in, or people working on this kind of network in Australia, in Japan, in South Africa, in Brazil, like all places around the world. And these are kind of the things we saw around this period. Actually, this is one of my favorite pictures, the left top one. That guy's called Flavio. He's living in Sao Paulo. And I think like a month after the launch here in Amsterdam, he made a t-shirt himself with the logo of the Things Network. I have no idea how he got it. Probably just copy-pasted it from a website or something. And he just started organizing events, just explaining the story about rolling out these kind of networks. Well, there you also see a Facebook page about Brazil. I think this is from Argentina, this meetup group. This is like a little bit more recently, but like in central Switzerland, they like created a whole marketing package with t-shirts, stickers, all kind of cool stuff. And they made sweaters in Italy, so it went really fast. And if you look at the map now, this is more or less what it looks like. So we have over 400 communities. So that means that there are 400 cities worldwide that have some kind of local groups that are rolling out this network. So across 85 countries, and actually it's now, I think, even 13 or 1400 gateways that are already connected. So these gateways are the antennas that are building, or creating this kind of network coverage. Cool. So what can we do with it? A few examples. First stolen car was tracked using LoRa. So like a car was stolen. Someone had a small LoRa device, like the one I just passed around, could pretty easily see where the car was located based on like the antennas that received the signal. Not sure if there was GPS or anything on it, but at least in no time he had his old car back. Smart mouse trap. So every time a mouse is being trapped, you get a signal. Pretty handy, I think. This is a fun use case as well in Arnhem. This is a air quality bird. Like in the beak you see the sensor, if you look closely, and in the tail you see the antenna. And they deployed a lot of these kind of small birds in the industrial area around Arnhem, and like you can live monitor the air quality in the surroundings. This is a project here in Amsterdam, together with the Waag Society. And they also made like these kind of air quality kits, which they put on a lot of primary schools in Amsterdam to monitor the air quality. Because like it started off with this project that there are like there's an institute in Amsterdam or like national wide that has the very big air quality sensors deployed in the city, which are super expensive. Quality is very good, but because they're so expensive, like there are only like few in the whole city. And it doesn't say a lot because all the traffic and stuff that's running around in the city. If one is standing in the middle of Amsterdam, it doesn't say anything about what's the air quality like in the eastern part. So they kind of made these kind of things to be deployed, low-cost sensors for anyone to use and anyone to like start building him or herself. Flood Network is a project in the UK around Oxford, and they are like distance sensors which they can place over rivers, and with that you can monitor live what the water height is around these kind of rivers. Pretty handy for early flood warnings. And the final example here is from Safecast, which is initiated after the meltdown in Fukushima in Japan, because there was very little data available about the real impact of that disaster. So just a small group was formed, and they started like these kind of small sensors, developing these sensors to detect this radio, like the radioactive levels. So they deployed it, created a bunch of them, gave it away to a lot of people in that area, and those people started biking or running around with these kind of devices, gathering real data, which is then plotted on a map. This is like one of the early days measurements. And there you see, like in the bright part of that image, that's like the area where with a lot of radioactive waste, which was actually like the results were that it was much, at least there was a very small stroke, which goes much further inland than they expected, but it's pretty small as well, this area. So at least this provided a lot of very useful insights for the people in those surroundings. So this is where we are, a bit 2 years later, with a community of over 20,000 people in 400 cities. And we're still growing ever since. And like one of the things why we grew this fast, because we have a lot of like people worldwide connecting gateways. Everything we do is open source, so we have people contributing there. Even if you're not very technical minded, then you can still contribute by building communities, promoting stuff, managing your surroundings, or managing the community. And we have a lot of like, we have a big platform as well where people can share their stories, share tutorials about the technology and the devices they created themselves. I have 2 slides to try to make it super simple about like where we're standing now. So like these are the nodes, like all the smart devices which connect to the gateways. The gateways then are all connected to basically our global server of the Things network, And with an API or whatsoever, you can like get your data to your own application. So basically the physical infrastructure that's very well, nicely decentralized, but we still run everything on the central server. So the thing what we are working now pretty hard on is also to make the central server decentralized. Started to do some experimentation. So now there's a party that's taking up like this network server site in Australia and one in Switzerland. And we started working with a partner in Italy as well to further decentralize this network and avoid that thing, like the breaking, avoiding or making the whole network more stable. And that was my presentation. Thank you. Any questions? Yes.
I'm coming.
So who pays?
Good one. Yes, like several ways. It started off like I saw the image. Actually, like the very early days, it started just with a group of hackers, group of developers, starting building the first infrastructure beta version, just in their like evening and weekend hours. And we had a few partners paying for the gateways, and that's where it started with. So it grew. We received in the beginning a few subsidies to like develop this further. And what we actually do, mainly related to this, because you can do this yourself just by copy-pasting our open source backend, but not everyone is able to do it, so you can also ask us to do it. And then we have basically a different party that's going to help you set us up for what you pay.
I mean, you've got the central server and you've got all these areas.
Yep.
Somebody's got to pay for those.
Yeah, true. So we do provide some additional consultancy services, workshops, these kind of things. Yeah.
Yes.
So if people set up a central antenna,
Yep.
do they have control of the data that flows through that hub, or does it all go through this network?
So how it works, like every message you send is encrypted. And so the basics of radio is that like these packets are flying around through the air and everyone can pick it up. So if you have a gateway, then you can pick up all messages.
Right.
But it's not that useful if you don't have the keys.
Yeah. So my question though is, does the community that puts the gateway together, do they still own their information?
No, like only the people that create like the application for like where the data ends up, in what kind of applications, that's the person that owns the data. So we also
Okay.
don't store any data.
I was just curious.
Yeah.
May I ask any question?
Hi, Laurens. I had a question after the workshop from last week. We talked during the process a little bit about whether it was possible to not only send to the things network from the node, but also take from the network, like reading back.
Yep.
But we were talking about how that's more like a one-way thing. So afterwards, I was reading a little bit on this, and I have a question about what I read, and I really don't know if you're the person to ask, but let's
say
try.
again, about?
So I read that the
All right.
LoRa chip is perfectly capable of sending and receiving these things, but it's the LoRaWAN network that doesn't allow to do that. And I was wondering if you can say a little bit more about why it cannot be a two-way sort of traffic, because I think
Yeah.
that would be interesting to.
Yeah. All right. So
Yeah.
basically, there are like two things. First of all, like at least the way how you work with it is that the end device always has to initiate contact to the server. So it can receive downlink message as well, but only directly after the device sends its signal. So you can also have also different modes where like the device is always listening to messages coming from the server. For this, you cannot do it with the kind of hardware you use during the workshop. So you need to have like specific hardware for that. Other thing is that's very battery, like it consumes a lot of battery power, energy. So it's not really feasible to do that like on a small like small size battery, so you have to find a way how to provide it with good energy source. And at this point, we're not supporting it yet. We're developing it, and I expect to be supporting it in like 2 months or so. So like the network where the device is connected to, that also should support this communication. I don't know if that answers your question. If you have real in-depth questions, then that's the guy behind you should contact.
Thank you.